This is a brief video on converting frequency to pitches. When we do a voice evaluation, we are going to take frequency measurements of the voice, what's going on in the conversation, the average, the highs and lows. We'll take a fundamental frequency of the voice, so what's the common pitch level, and then we'll also do a measurement of the range of the voice. Now, when we take those measurements, we are collecting objective data on how many cycles per second the voice is vibrating at. To compare those, we have to convert them to pitches because pitches are a perceptual label for what we hear. So one's what we measure, one's what we hear. The important thing to keep in mind is that you can't directly compare frequency numbers. Like if you had somebody at a frequency range of 500 hertz, that's really kind of meaningless because I don't know where that 500 hertz is located. And the distance between our pitches or our perceptual assessment gets larger as we go up. So the short answer is you can't work with just direct frequency numbers if you want to compare them. So what we do is we convert them to pitches. Pitches are used in music and they're labeled with letter names, and then depending on the system you use, they may also be labeled with an octave number. There are 12 semitones in an octave, and you don't really need to know a ton about music. You just need to be able to kind of plug and chug some numbers here. Although the more you understand, the easier it'll go. So if we look at one of our standard evaluation forms, these are some of the phonation or hertz pitches we might take. When we do a conversational one, you do an open-ended question for about 30 seconds to a minute. You're going to record the average and then the range in hertz. But look, we want an average. What was the average pitch and what was the pitch range and what were the semitones? So what do we do for that? So if we come back to this page, we have some options for converting hertz to pitches. A couple of these are lists. This one is a calculator. And then there's a chart here that shows it related to piano keys that I find can be helpful to make sense of it if you know how the piano works, but don't use it to calculate. We'll start with this chart. This is my favorite one because it organizes it by octaves, which is meaningful to me. So if we took a measurement of 124.6 hertz, I would look on this chart and go, oh, I've got 124, but I don't have 0.6. Well, what we're doing is we're going to the closest pitch because note it doesn't go exactly by hertz. So in that case, 124.6 hertz would be B, that's the letter name, and then I go up here and the octave is 2. So that's going to be in the middle of the typical masculine range. If I were to get a measurement of 732.1, I keep going up and notice the range is much bigger here. 732.1, is it closer to 740 or 699? Well, it's actually closer to 740, so that would be F sharp 5. And I would say we're probably not hearing those two pitches about the same individual or from the same individual. So then on my evaluation, right here for the average, if that 126 was my average, I would put my B2 here. That range we looked at probably, like I said, wouldn't work with the same person, but what I do is I find the two parts of the range from the hertz I got and write them in here. And then we have to figure out the number of semitones between them. So if we had a range of G2, right here, 104 to 208, that would be 12 semitones. So I can count them out. I start at G sharp 2, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I go from one note to the exact same note an octave above, it's going to be 12 semitones. If I had a range from G sharp 2 at 104 hertz and the range went up to B3 at 247 hertz, I would then go from my 12, 13, 14, 15. So my range is 15 semitones. And then that gets recorded here. For the habitual pitch, you'll take the same hertz measure 3 times, You'll average that, and then figure out the pitch. And note there's some normative data here. When you're doing your measurements, think about if this makes sense. Based on the speaker I have in front of me, does the range fit? Sometimes we measure it incorrectly. And if the range doesn't make sense for what you're hearing, then you might want to try it again. The fourth measurement we do is physiological pitch range. So that is going to be going all the way to the lowest note and then to the highest note. And we're going to have a much larger pitch range, we hope. And there we're looking for a norm of greater than 21 semitones. So let's go back and just briefly look at the two other charts, because I like that one the best because you can kind of skip over with the octaves. This is another chart, and what you can do is you can go find your pitch. So we had 124.6, which here they're a little bit different because we rounded up to 124 in the other chart, but it comes out to B2 once again. And if I was looking at my 732, I can come here and go, okay, there's the F sharp, that's higher, but it's a lot closer than the F itself. So that would be F sharp 5. And I always report things with sharps versus flats. If you're familiar with music, I don't have a good reason for it. That's just the way I do it. And here what you would do is, again, you just count the steps to figure out your semitones. If you don't like doing it that way, there is a calculator. And you pop in the hertz. So we had 124.6. And it pops out B2 plus 16 cents. Ignore that part. That's telling you precisely what 124.6 hertz is. We're just concerned about the letter numbers. And let's put in our 732.1, and we get our F sharp 5. So note we got the same pitch on each of the charts. They're just different ways to do it. In this case, you're still going to have to calculate what the semitones are, probably using one of the other charts or based on what you know about octaves. So when you're doing the evaluation, you'll notice that the hertz measurements on this form are in bold. You're going to get that data from your app. And then these things that are not in bold, the pitches and the semitones, you're going to calculate later. You don't have to do those during the session. So place to start is the music introduction or review page. And you go down the tab that says converting frequency to pitches, and you'll be able to find those charts.